Today I'm going to talk about degenerate semiconductor, current flow, and carrier. Let's start. First, let's talk about degenerate semiconductor. There are three energy band gap in here. And first, this is intrinsic semiconductor energy band. There are the original energy band gap. Then if we dope something a donor or acceptor, then the energy band gap will be changed like this. This is n-type semiconductor energy band gap, and this one is p-type energy semiconductor band gap. So based on this energy band gap, if we doped a lot to semiconductor, this Fermi Dirac level will be going up or down very high. So if we dope a lot, this Fermi Dirac level will be same to conduction band level. So this one is Fermi Dirac level and conduction band level will be same in here if we dope a lot. So if this semiconductor change like this, have this energy band gap, this semiconductor will be work like metal. So after change the metal, this is not semiconductor anymore. So if we doped a lot and changed semiconductor, we called this semiconductor to degenerate semiconductor. Degenerate semiconductor is lose which semiconductor lose this original semiconductor's characteristic. Then let's talk about current flow. The electron can move in free space like this. If electron collide with something, it can change their way. However, after finish the moving, it come back to the start point. However, if electron get forced from another place, the electron move like this, and the start point and the point will be changed. So in this case, we call this moving like drift. So we can calculate the drift velocity in this situation. So there are very complex equations before to calculate this equation, but in conclusion, we can get the two equation. So we should remember this equation. So in conclusion, J equal Qm mu E plus J equal Qm mu PE is which we want to know about the velocity and current. So yes, we should know about this equation in conclusion. Then let's talk about carrier scattering. There are two ionized donor and acceptor. If electron and hole move to get close to the ionized donor, the electron move to get close. Electron get close to ionized donor. However, the hole move to far away from ionized donor because their polarity. Then, however, in ionized acceptor, electron far from the ionized acceptor and hole get close. The hole will be close to ionized acceptor. So this means carrier scattering, that electron and hole move this way. Then let's talk about lattice scattering. Every material have their own lattice, and there are electron is in here, fixed in here. However, if this lattice get higher temperature, this electron will be shivering, so they are moving in here. So if another electron moves to near in here, that electron can be collided with this lattice. That percentage that percentage will be higher. So this means lattice scattering. And lastly, let's talk about surface rough scattering. Every material has their own surface, and those surfaces are very rough. So if electron move to that rough surface, that can happen the scattering. So in conclusion, we learn about three situations about scattering, and if we calculate the time to the drift velocity, phonon plus impurity plus roughness means equal to this time. So we can calculate the total time of flight based on this equation. Lastly, let's talk about high field effects. This graph means carrier velocity and electric field. So in conclude, based on this equation, we can know about the velocity and electric field are potential. So we should use this rule to make the semiconductor get more higher velocity, and current flow will be more better. Yes. So today we review about carrier velocity, degenerate semiconductor, and current flow. Thank you for watching my video. Bye.